Hello, everyone. My name is Prasenjit, and welcome to the third session in the series of sessions where we discuss and learn about the Google Cloud Architect Professional Certification. And in today's session, I would like to cover about a very important service in the Google Cloud platform, that is the Cloud Identity Service. So we will try to dig deep into cloud identity and understand what it is, what it does, and what are the various features present in that service and how you would use that service effectively. So cloud identity is an identity as a service, IDaaS solution that provides unified identity, access, application, and endpoint management platform. So this is a complete identity management platform. So you get unified identity, you get access control, you get application management, endpoint management. So comes as a identity as a service platform. It offers a variety of avenues to enable various users consuming Google Cloud Platform to connect and access resources. When you sign up for GCP, you will create an administrator account that will have access and ownership of your cloud identity, and you'll have to set up a billing account. For a single user or a small company, this is pretty straightforward and easy to do. But imagine you're working for an enterprise, then the process can get pretty complex. You can create multiple billing accounts depending upon the size of your organization. So that'll get complicated. So for a huge multinational company, which may have dozens of subsidiaries under its umbrella, for example, it will not make sense for one administrator to be responsible for paying all the bills for all the subsidiaries. So there we see a use case for identity service. So your organization's cloud billing account pays for the Google Cloud projects, Google Map platform projects, and it can be linked to one or more projects. So during the cloud identity setup process, you will be asked to add your domain, then verify your domain with the DNS records, and then you create cloud identity users. Typically, a TXT record will be automatically generated in your DNS records to verify your domain. But you may sometimes have to do this manually too. And you may be working at an enterprise that is spinning out new organizations, for example, or that has not yet adopted GCP. So you will need to enter a vast amount of information to do this. So what are the security principles in the cloud? Now, with the advent of cloud computing comes a new paradigm for how enterprises build and manage the technology stack. In the pre-cloud traditional computing world, we thought about computing as a multi-tiered or an n-tiered architecture, where the front end served content, the middleware handled the application logic, and the back end was typically reserved for database or data stores. Now, that is one model. And in the traditional monolithic application model, the identity and access management, or IAM as we call it, was typically brokered within the application. So if a malicious user gained access to that monolith application, he would have full access to everything within the monolith. So that is a threat. With the rise of service-to-service communication, microservice, inter-process communications, there is reinvigorated emphasis on following the principles of least privilege and separation of duties as applications are broken down into smaller chunks. So while microservices may increase the complexity of the enterprise in some ways, it minimizes the threat surface because the authorization is required to grant access to all the services. There is no single monolith that would grant access, and if that is compromised, everything else is compromised. In this case, you have different services, but there is one identity service that actually allows you to have access. Now, because these services are divided into smaller chunks, loosely coupled chunks of microservices hold fewer responsibilities, and The same security principles apply in the cloud. At the core, the most important security controls for preventing malicious activities exist. So as we design solutions for the cloud, we can think about how a hostile actor may gain access to a service and think about how we can minimize the impact if the service were compromised. Now, there is a model which we can use to minimize vulnerabilities. That is called the AAA model, AAA, which stands for authentication, authorization, and accounting. Well, AAA security is one of the core security principles of the cloud. So whenever you think about identity or cloud-based security, if someone asks you, then always think of the AAA framework to answer your questions, and that makes your thought process and your applications easier. So what is AAA? So it stands for authentication, authorization, and accounting. Well, you all know what authentication is. It is just the act of providing your identity. This is referred to as identity assertion. So you're just providing your identity and authenticating yourself, whether you're the correct person or not, whether you're the correct persona who would be provided a set of privileges. So that is authentication. The second A stands for authorization, which means what set of privileges are you entitled to? A set of privileges or permissions, as we call them in GCP, is that which grants user access to certain resources. So this can also be called access management. So that's authorization. Now, the third A in AAA stands for a process called accounting. Well, accounting is also called auditing in Google Cloud jargon. So you can think of it like the ability to audit what has happened, like who has got what access, whether the access that a particular persona got was correct or not. So these kind of things are verified in the auditing process, and the process ensures that a digital log or a trail for every user's access is kept, and it is ensured that these logs are immutable. No one can make changes to those logs and derail the audit trails. So that is what accounting is all about. So when you think of security, always think of authentication, where the identity is proved, authorization, where the privileges are asserted, and accounting, where the audit is done, whether a certain authentication and authorization went according to plan or if there was a breach of the plan. Well, we learned about AAA. Now let's move on and understand another concept in cloud security or cloud identity service that is called the least privilege and separation of duties. Now, least privilege and separation or segregation of duties are two building blocks of security for cloud computing systems. It also applies to physical security, but here we are focused on access management on the cloud. So the principle of least privilege states that we should provision an individual user or a system account with the least amount of privileges needed to perform a job. So one should not just assign a complete set of privileges to the user when he doesn't need it. So you provide the least amount possible privilege, and if that is not sufficient, then a little more is added. So it's not just allowing privilege, not a bit more than whatever is needed. So that is about the least privilege principle. Now, another security principle is the separation of duties. It is the idea that you should separate all the duties needed to perform a critical business function across multiple users, so that in the event one user is compromised or goes rogue, the whole system or the process is not compromised. So one person should not be the god of the entire cloud infrastructure. The privileges should be separated, duties should be separated. Now, how is this done? This can be done in many ways. One of the most famous and effective ways of doing this, like providing the least privilege and separating the duties, is by using RBAC. RBAC stands for Role-Based Access Control and has become a standard for IAM in the cloud in the last 15 years or so. And in the RBAC model, what we do is we define roles for the organization and for the user. And it doesn't matter whether these are individuals, groups, or service accounts. And for each of these roles, we define the least amount of permissions necessary to enable the user do their job. Well, those who are curious, I can tell them, similar to RBAC, there is another way in which we can apply the security principles or privileges. That is called ABAC, or Attribute-Based Access Control. It is also becoming more prevalent nowadays in the cloud. What does it do? It offers the ability to allow or deny authorization to a resource based on conditions, such as blocking a user from accessing outside work hours, or blocking access from a user coming from a certain geolocation or country. So these are also present, like these kind of ABAC rules can also be present. This is not covered in this particular exam, but it's a good to know that RBAC as well as ABAC can be used to deny or allow authorization. Well, now that we know about the security principles in the cloud, AAA, and about the principle of least privilege and distribution of access, and about RBAC, let's move on to cloud identity. Well, as I mentioned earlier, cloud identity is the identity as a service solution that comes from Google Cloud, and it provides a unified identity access application and endpoint management platform. Now, cloud identity is an IDP, or identity provider, that leverages the same identities to use Google Workspace as well as Google Cloud, and it integrates various third-party applications. Cloud identity supports security assertion markup language. You might have heard of the term SAML, SAML, in security. So that stands for security assertion markup language, kind of language through which you can provide access control rules, mostly used in single sign-on apps and identity apps. And cloud identity, apart from SAML, also supports LDAP, which is lightweight directory access protocol. It's similar to what Active Directory is. And SAML provides an open standard for exchanging authentication and authorization data between different parties. Commonly, these parties are identity provider, or cloud identity in this case in Google Cloud, and a service provider, which can be a third-party application, something like Auth0 or Okta. Okay, so third-party application, or it can be between cloud identity or any application in the cloud where you want to make a single sign-on. For example, you want to integrate your Atlassian tools with Google Cloud Identity, and you want to use the Google Cloud Identity to log into your Atlassian without using your username password. Or say you use HashiCorp Vault for your keys, storing your keys and secrets, but to log in into HashiCorp Vault, you don't want to log in with a token or with a user ID password. Instead, you want to use the cloud identity token and do a single sign-on to the HashiCorp Vault cluster. So these kind of use cases allow you these kind of use cases require you to create integrations between cloud identity and the third-party application. We'll come to that and some examples down the line. Well, and as I said, LDAP is an open cross-platform protocol that is commonly used for directory services, something like Active Directory. Now, so we know about these concepts. Now let's know a bit more about what Google Cloud Identity is. So basically, it has two editions. One is a free tier and another is a premium tier. In the free tier, you can perform user security management via 2SV. You can perform basic mobile device management. You can leverage Google Cloud Directory Sync and gather audit logs from the admin console. In the premium tier, you get access to advanced mobile device management, secure LDAP, Google Security Center, big data log exports, and a CLA of 99.9%. So many companies use third-party tooling that performs a lot of premium tiers functionality. So they go with the cloud identity free tier and integrate with their third-party tools. So that is allowed as well in Google Cloud. So that is about the cloud identity. And now let's move on and understand how managing users in cloud identity works. So as a cloud architect, it is important that you understand the following points when we are talking about cloud identity. Number one, we should know how to create or import user accounts into cloud identity directory. This is very important. Now you can look this up and try it yourself, but I'll tell you the steps. So you need to know how to create or import users into cloud identity, how to manage the user lifecycle, including when users are onboarded, when they switch to new roles, and when they leave the organization. So as an architect, you should have a clear picture of how the entire identity lifecycle for a particular user works. And then you should know how to leverage 2SV mechanisms to give you more confidence in non-repudiation of your user identities. And finally, you should understand whether you will use SSO, single sign-on, or whether cloud identity or a third party will provide your identity. So as an architect, you should have this scene clear. All right, so going to the first point that I said, how do we create users and groups? So users and groups are created in cloud identity, and this can be managed from the browser. You can just go into admin.google.com. So this is not the GCP console. The users and group that you create receive Google identities, and they can be consumed by the cloud IAM for role permission management from the GCP console. You can create identities in multiple ways, actually. One of the ways is by bulk uploading them. So you go to admin.google.com, and then there you can bulk upload them from CSVs. You can import them. You can even manually create them. You can think of cloud identity as one layer of abstraction higher than cloud IAM. So you first create users and groups that authenticate to the cloud in the admin page, admin.google.com, via whatever mechanism you choose. Then when you launch the GCP console to access the cloud IAM, you can manage the authorizations for these users there, and assigning them roles that manage permissions to cloud resources can be done here in the cloud IAM. And cloud identity roles are focused solely on managing authentication and information of users and groups in the admin page. Now, GCP roles are provisioned and managed via GCP console, and the access is enabled to the cloud resources from there. Well, another way to provision users is using GCDS, which stands for Google Cloud Directory Sync. Now, GCDS integrates with LDAP and requires minimal effort to create users. So this is a recommended practice. So remember this. If you have similar questions for the GCP exam, you can use this as a recommended practice. And this also comes handy when you're provisioning a lot of users and you have LDAP. So Google Cloud Directory Sync is a very easy way to sync all your users on the LDAP onto this Google Cloud platform. Now, users can also be provisioned via bulk uploads by manually creating them in Cloud Identity, as I said, and using Okta or any other third-party tool, or even by programming them in the Directory API with the Admin SDK. Now, GCDS provides a one-way directory sync from your Microsoft Active Directory or any Linux-based LDAP server to synchronize your users, groups, organizational units, aliases, profiles, shared contacts, and it can match everything that you have on your LDAP server. In addition, the LDAP server is not updated. As I said, this is a one-way sync, so you don't have a risk of your LDAP server getting messed up or the data being tinkered. So very safe way to migrate your users onto GCDS. Now, you can use custom mapping rules, and GCDS offers a simple user interface that enables you to simulate your configuration before you actually run it. Now, let's talk a bit about different roles. The super administrator and the org admin roles. Well, so talk about roles in Google Cloud. The super administrator role can be a super admin in the cloud identity, and the super admin is granted the GCP organization admin role by default. So by default, the super admin is an org admin in GCP. Now, super admin users manage user and group account lifecycle as well as security settings of the organization from the admin console. These super admins have full visibility of cloud identity and GCP environments. And when we are talking about a multi-organization setup, the super admin has full visibility of all the organization's GCP environments. So super admin is, you can say, the god of all the users. So it has god level access. Well, organization admins are a hierarchy below the super admins. Org admins have ability to define IAM policies, grant other users IAM roles, determine the structure of the resource hierarchy, and delegate key cloud responsibilities to other users via different roles. Now, org admins cannot perform actions such as creating folders unless they grant themselves the appropriate role. So it's an administrator's role. So it doesn't do mundane user tasks, but it can do user tasks by creating policies and allowing themselves access to do that. Now, let me talk about another concept here, which we call hardware security keys. Well, it is important that we secure our super admin accounts. As I said, they are God level access. They have God level access privileges. So we need to secure these super admin accounts. So you need to know ways by which this can be done. So one of the ways is using hardware security keys. Super admin users will always bypass single sign-on and can authenticate with Google. They have the most powerful permissions, and they do not need to be leveraged daily. So it's important that you have to limit these users, because the more powerful the user is, it can be used as a special user who comes in at a certain, when there is some emergency, only then this user comes in and rescues. Otherwise, this user should be put away in a safe place and should not be used. Just as in Linux, it is advisable to use a normal user account and use sudo to run admin accounts instead of directly logging in as root. Because if you can inadvertently, you can make certain kinds of mistakes, human errors or mishaps, or you run a script and because of the privilege this user has, it can do some damage. So better to limit these users to less number of accounts. Like you should not have more than 3 or 4 accounts, and you should ensure that you provide rigorous protection to this account which have super admin privileges. Now, apart from that, you can keep a backup of the security key in case your super admin loses a security key. You can have proper recovery options in place and protect backup emails with 2SV. And you should ensure that there is more than one super admin to prevent any kind of single point of failure or lockout, but do not provision too many super admin users. And you should separate duties by delegating the roles of super admin and the organizational admins, because we know about the principle of separation of duties. So we should apply that here. Now, how users authenticate to GCP? So how does authentication happen? Well, there are three primary ways for users to authenticate into Google Cloud. One is via Google authentication, normal Google authentication, user password without single sign-on. The second way is with single sign-on by Google authentication and cloud identity as the IDP. The third way is single sign-on, but not using Google Cloud Identity, but using an external identity provider such as Okta, Auth0, ADFS, Ping Identity, and so on. The first option is the most uncommon. Most organizations prefer to leverage single sign-on for security and governance purposes. I'm talking about enterprise organizations. They would prefer single sign-on and not have a list of passwords for different users. That's even more unsecure. So for organizations that strictly use GCP, the second option would be the most common that you would come across. And it doesn't require any other vendors and has a minimum overhead because you are using or leveraging the Google Identity Service as the IDP. Most enterprises that use the third option, because they already have this identity provider in their infrastructure, or it is simpler for them to onboard and provides them interoperability between cloud providers and on-premise environments. Say they have Okta and they have multi-cloud and they use Okta to authenticate Google Cloud as well as AWS as well as Azure. So normally these are the reasons that different companies would like to use third-party identity provider. So you have to just be aware of these options and that they are present. And well, Google supports all of these three options. Now comes the two-step verification or the 2SV that I was talking about. So what is two-step verification? You might have heard about two-factor authentication. So these are all the same concepts. So two-step verification is where the Google Cloud calls multi-factor authentication across the enterprise. So for privileged users, this is mandatory and should be mandatory. And you will have to perform a risk assessment for unprivileged users and determine the value of two-factor authentication or two-step verification. So you can implement this 2SV in several ways. One is with the voice call or SMS that comes into your mobile phone, and then you get a code and you provide that code. And the second option is you can download the Google Authenticator app. So you check in that Authenticator app and there is a code that comes in and gets refreshed every few minutes. So you can use that code to authenticate yourself. That is a way to do that. And there are also certain ways where you can have backup codes with you and use them. There is another way where you can have push notifications that you want to authenticate. Are you the right person? That push notification comes to your mobile device and you accept it or deny it. Based on that, one of the steps is completed and the other step is your identity password or whatever you enter. Another option is using hardware security keys. So these are the most secure mechanisms. So you have a hardware security key and where random tokens are generated and you use them as one of the steps of verification. So there are lots of these hardware tokens available. One of them is called FIDO token, FIDO U2F, which stands for Fast Identity Online Universal Two-Factor. So this is a token. It was, I guess, invented, brought across by PayPal. So that's one of the very famous token and provides a high level of security when it comes to hardware based security keys. Well, the final thing about the identity service and security in the cloud is security auditing. Now, there are various ways to ensure that you're adhering to a AAA security model and best practices in the Google Cloud. And security teams often leverage multiple elements of an audit trail to ensure that they know what is going on. So if you go to the admin tab in your Google Cloud console, you can review the user settings and monitor user password strength. So you can generate audit reports and provide some visibility into user logins and other audit log across your services. You can set up some custom alerts there to be alerted whenever any suspicious activity is logged. You can use the security center if you are using the cloud identity premium tier to perform advanced security and threat detections. We will deep dive into security auditing in one of our another lecture sessions, which is upcoming. So basically, this was an overview. As I said, these lectures are not tutorials. So I give you tips and basics about every aspect that is covered in the Google Cloud Architect certification. And also those who are not appearing the certifications, these kind of discussions help you enrich your knowledge about different aspects of Google Cloud. Hope you like this session. Put in your comments or questions. I'll be happy to answer them. Thanks a lot for your time. Looking forward to see you in the next one.